Okay, so everyone knows that when a lens system focuses rays to a spot, the smaller the spot, the better the image quality. In other words, higher the MTF or modulation transfer function because lens designers quantify image quality using the MTF. So physically, you can understand this because an image is composed of a superposition of spots or point spread functions, right? Point spread functions. And the smaller the spot, the sharper the image. But why is it mathematically that when the spot is smaller, the MTF is higher? Okay, so one way to understand this is to think about boundaries. Because, I've got boundaries, you've got boundaries. Just kidding. We're not talking about personal boundaries. We're talking about bounds on a spatial coordinate, such as this, for example. Let's say you got a diffraction-limited point spread function, the area disk. It's got wiggles on the edges, right? But what if you confine the PSF, the point spread function, within this region of the curve, where it looks like a bell, a Gaussian curve, right? And so what if we just approximate this curve with a Gaussian function? If you do that, you end up with this, for example. And, the MTF is the normalized modulus of the optical transfer function, which is the Fourier transform of the point spread function. So if you take a Gaussian approximation to the point spread function, a Fourier transform of the Gaussian is a Gaussian, which is this right here. Okay, just ignore the other half. So the Gaussian point spread function has a half width WP. The Gaussian MTF has a half width WMTF. And if you take the Fourier transform of this, you get this. And if you look at what's in the exponent and relate the two, you can write the width of the MTF, of the Gaussian MTF, as a function of the width of the point spread of the Gaussian point spread function. Put it together and you get this relationship here, an inverse relationship, right? The smaller the width of the point spread function, the larger or longer, broader the width of the MTF curve. In other words, higher MTF curve. And that's kind of how to see mathematically why it is that a smaller point spread function gives you a broader MTF curve. So this is the nature of Fourier transform or Fourier transform pairs, right? It takes a lot of spatial frequencies to synthesize a pulse, and this is kind of like a pulse, right? That's why a delta function has a Fourier transform that is really, really broad. And this is kind of what I want to talk about tonight. Thank you for your time. Bye.